Hey everybody, how's it going? This is going to be my attempt number 2 to solve this problem. I had a working solution that just gave a timeout, and it gave a timeout right here. And let the record show, I called that it was going to give a timeout because I knew that there would be a test case that would abuse the n-squared nature of this problem. My solution would have worked if there had been a restriction that required that numbers in the original array be unique, and no such restriction existed. So what I did is I quickly glanced at the solutions, and I noticed that people. Well, hold on. Let me read the problem. You're given two integer arrays, nums1 and nums2. You're tasked to implement a data structure that supports queries of two types. Add a positive integer to an element to give index in array nums2. In other words, you can increment something in the original array. Count the number of pairs I, j, such that nums1 of I plus nums2 of j equals a given value. Implement the find some pairs class. And that sounds pretty good. And so I clicked on the solutions tab after I'm like, okay, I'm defeated. I don't know how to do this. And I noticed multiple people saying that they used a hash map. And I realized that I had ruled out using a hash map initially because I misread the question, thinking that both nums1 and nums2 could be updated. But that is not the case. Only nums2 can be updated, which means nums1 is always static. That opens up a world of possibilities for how we store nums1. Moreover, at most 1,000 calls are made to add and count each. So they're basically expecting that to be an expensive operation. Otherwise, why wouldn't it be up to, 10 to the 5th operations to add and count? So I got thinking here. Where's the reset? Reset. Let's redo this. So nums1 is never changing, right? Nums1 like this. Counter nums1. Okay. And then nums2 is changing, but we can track it at each different iteration. We don't actually need to calculate the indices I and j every time. We don't. Now, where that would come into if we needed to compare everything with everything else, then yes, that would definitely be a problem. But I'm saying that, well, we don't. So let's say counter of nums2, right? And then we're going to assume that it maintains a consistent state. And then we need to obviously save the original array. Nums2.copy. I could probably just say nums2. And whatever. Okay. Yeah, so original value equals self.n2 of index, and new value equals self.n2 of index plus val, right? Yeah. Now we're going to say self.c2 of original value minus equals 1, and self of new value plus equals 1. And then if this equals 0, then DL that. I think that works pretty well. Now cnt equals 0, and then we're going to say for value, comma, count in self.c1.items. So that's going to be everything that was in the original C1 array, or in the original nums1 array, excuse me. And then d for desired equals total minus v for value. If d in self.c2, just self.c2, then cnt plus equals every index from here, so in other words c, times everyone from here. Yeah, so the value at location D, and then that should be cnt. Wrong answer. Okay, 27 0 0 0 0 0 0 0 0 0. Something strange is going on. Something strange indeed. So let's go back here. So it did work for this one, but it seems to be failing here. Oh my god. Do you see what I did? That was pretty dumb. Okay, it passes. Make sure I didn't put any print statements in. Yeah. I guess, at least in this case. Well, let's see if it passes first. There we go. Yeah, that's pretty good. I guess second time is a charm. I don't know why somebody would like to see me struggle and fail for 30 minutes, but I guess I will link the original attempt, which I recorded literally moments before I started this video. Anyways, see ya.